Welcome everyone. Thanks for joining our webinar. My name is Lisa Rosenow and I'm with Evergreen Technology Consulting, or ETC for short. I'll be your host today. This webinar will be the second episode of our 7-part series about the 2018 WSEC commercial provisions. We will be focusing on key changes between the 2015 and the 2018 WSEC. The primary topic we'll be covering today is mechanical systems. Before we get started, let's cover a few housekeeping items. We have a lot of people joining this webinar today, so everyone's audio will be muted to avoid background interference. If you have questions, feel free to post your questions in the Q&A during the presentation. At the end of the presentation, we'll walk through a few of your questions. After the webinar, we'll put together a list of all the participant questions posted along with the responses from our Energy Co technical team. And then we'll send this out as a supporting resource to everyone who's registered. If you're experiencing any technical difficulties, please communicate this to us via chat. We'll do our best to resolve whatever issues you may be experiencing. This webinar is being recorded and it will be posted on our new WSEC website. Okay, so let's get started. So first of all, who is ETC? Our team provides technical support for the commercial provisions of the Washington State Energy Code. We provide technical support through our telephone hotline, via email, or through our online form. We also manage and provide technical support for the new WSEC Commercial Compliance Documentation web tool. We'll provide a quick overview today about this new tool in our presentation. Before we get started, we would like to extend our sincere thanks to the Northwest Energy Efficiency Alliance. They support energy efficiency programs and services throughout the Pacific Northwest region. It's through their generous support and the support of their utility partners that we are able to provide technical services and training for the Washington State Energy Code to the design and construction industry. So again, we want to extend our sincere thanks to NEA for all of their support. So now let's talk about what we have planned for training. Our training today is episode 2 of our 7-part series about the 2018 WSEC commercial provisions. On June 3rd, we'll welcome Heather Burpee from the Integrated Design Lab and Supriya Goel from the Pacific Northwest National Labs as our guest presenters. They will provide an introduction to the new requirement in the mechanical provisions called Total System Performance Ratio, or TSPR. They will explain what this requirement is all about and will provide a step-through demonstration of the new web tool that's been developed that runs the necessary calculations for this requirement. Note that if you are not available to join us on June 3rd, they will be offering the same demonstration again on July 1st and August 5th. Later in June, our technical support expert, Dwayne Llewellyn, will provide part 2 of our 2-part training about the mechanical provisions. Then in July, we'll cover lighting and electrical systems, additional efficiency credit accounting, and service water heating and refrigeration systems. Our training schedule is posted on our WSEC website. So here's a quick update about the 2018 WSEC. The adoption date for the WSEC, as well as all of the Washington State building codes, has been postponed until November 1st, 2020. This extended schedule provides extra time to ramp up all the new code requirements. The 2018 WSEC has been posted by the Washington State Building Code Council on their new website. Note that they just recently completed a few errata items, which have been incorporated into the second printing. This document is free to download. So before we get started, we have a few words about code interpretation. This presentation represents ETC's unofficial interpretation of code intent. We've been doing this a long time, so we're able to offer a well-informed perspective. However, we have to inform everyone who contacts us for Energy Code support that our technical support team is not an affiliate, nor do we speak for the Washington State Building Code Council. Official interpretations of code intent are made by the State Building Code Council in response to official inquiries submitted to the State Building Code Council by jurisdictions. Note that some of the DOAS-related details that we'll cover today are topics that the SBCC has provided code intent clarifications about. So we recommend reviewing the available official interpretations on this topic that the SBCC has posted on their Answers and Opinions webpage. So today, we'll do a brief recap of the WSEC Commercial Technical Support and Compliance Documentation web tool. Then we'll get into mechanical. We'll explain how the mechanical systems chapter of the code has been reorganized. We'll talk about how the scope of the DOAS provision has been expanded, and then we'll cover various updates to the DOAS-related provisions. At the end, we'll provide a very brief introduction to Total System Performance Ratio to queue up for the TSPR training and web tool demonstration scheduled for June 3rd. So without further ado, let's get started. We are delighted to present to you the new WSEC Commercial Technical Support website. This web tool supports the commercial provisions of the Washington State Energy Code. Many of you have already visited this new website and explored the helpful tools that are available. The website has an Energy Code Documents portal where many of the WSEC official documents can all be referenced from one place. We have incorporated various integrated education resources, such as the FAQ tool. So, for example, you can go to this page, click on the select topic, and pick a topic that you're interested in learning more about. And then what will be presented is a list of questions that we have received and the responses that we provide. So now let's talk about the feature that has been developed for mechanical. So the mechanical tool supports new construction and mechanical alterations. We have a smart mechanical requirements list, which replaces the project-specific mech check form. We have a mechanical compliance documentation console, and within that console, it provides a portal to document project information. It runs compliance checks for equipment efficiencies, including economizer exception and additional efficiency credit multipliers. And it's also a place to document pairing of heating and cooling systems with associated DOAS. And in addition, it does generate project output summary reports that you can then turn in with your project documents for your permit submittal. Note that this is not a complete compliance verification tool. There are a lot of provisions in the mechanical section of the code, and it really depends on the type of project and the scope and all that. And so what this tool is doing is it focuses on common requirements that apply to most projects, and then the reason for providing this is that this will reduce the amount of details that then have to be verified by the designer in the jurisdiction. So it doesn't take care of everything, but it does take care of quite a few of the requirements, and it runs through some compliance verification for those requirements. So the list of project-specific requirements, unlike the Excel mech check form, which is a generic list of code requirements, the Smart Requirements List feature applies the answers you have provided to various general questions about your project, and it generates a list of energy code requirements that are specific to your particular project. Non-applicable requirements, they don't go away, but they're grayed out, so you have a customized list to work from. So we think that this feature is going to be super helpful because the mechanical checklist, recall, it's like 10 pages long. There are just so many requirements in the mechanical chapter. So by doing a little pre-filter and graying out those provisions don't apply to a project will make it more manageable. So in this particular example, the project doesn't have any hydronic systems, so everything associated with hydronic has been grayed out. So hopefully folks find this useful. The main event are the compliance verification consoles. This is where the user can enter information about their project and check various details for compliance. And so in the console here, we're taking a look at a single zone system, and what it looks for are the equipment efficiency requirements, and you can enter in any economizer exceptions that you're taking. You can apply the additional efficiency credit multiplier to your efficiencies. So it's checking lots of very useful details. And then the tool also generates output reports to include with your permit submittals. So everything that you've entered for all of your systems are included in this output report. So this summer, we will post webinars that will provide step-through instructions about how to use a new web tool for your compliance documentation. So for the 2015 WSEC, the tools that will be available or will continue to be available are the Excel workbook forms, so for envelope, lighting, and mechanical. And then the new online tool, it is set up for the 2015 code. It covers similar scope as the Excel forms with more detail, some expanded compliance checks, and lots of new support features. For the 2018 WSEC, the only tool that will be available for compliance documentation will be the online tool. So do check out those webinars, and once we get those up and running, to learn more about how to use the tool. And then feel free to jump in there and play with the tool, do some test projects, get the hang of it. And if you have any questions about how to use the tool, feel free to reach out to us through tech support. We would be happy to walk you through it and help you learn how to use a new tool. And so with that, let's move on to mechanical. One big change in the 2018 WSEC is that the entire mechanical systems chapter has been completely reorganized. The problem with the way this chapter is currently organized is that you often have to search through multiple subsections to find all applicable provisions for a particular type of equipment or system. For example, for a project with a gas-fired boiler, you have to look in 3 different locations to locate all the control requirements. So for the heating equipment and outdoor temperature setback requirements, they're in section C403.2. And then all the hydronic system control requirements for boilers and pumps are in multiple locations in section C403.4. So if you don't know where to look, it's easy to miss a requirement. Under the new organizational structure in the 2018 WSEC, it is now less likely that related provisions are located in multiple sections. It's not perfect, but definitely better than it was before. The hard part now is figuring out where all the provisions were moved to. So here's a high-level summary of how the mechanical system chapter will be organized in the new code. So under section C403.1, this covers load calculations, the new total system performance ratio provision, and new design standards for data centers. Under section C403.2, this covers design criteria such as system sizing, zone isolation, and minimum and maximum CFM criteria for ventilation and exhaust. In section C403.3, this includes all the equipment efficiency tables and specific equipment selection criteria, such as the requirement that packaged electric heating and cooling systems above a certain size must be a heat pump. This is also where all of the DOAS provisions are located. All of the general control requirements are grouped in section C403.4. So this is where you'll find thermostatic and off-hour control requirements, general hydronic control requirements such as pump isolation and variable flow criteria, and the DDC requirements. Section C403.5 is where you'll find all of the economizer requirements for both air and water economizer. In section C403.6, this is where you'll find all the VAV air system control requirements, including the high-efficiency multiple-zone VAV alternative to DOAS. All of the specific ventilation and exhaust fan system requirements are grouped in section C403.7, including occupancy-based controls, kitchen and laboratory exhaust, parking garage and loading dock systems, the ventilation system energy recovery performance criteria, and all the shutoff damper requirements. Section C403.8 covers all other fan requirements, including the fan power limitation criteria. All of the requirements for cooling towers and air-cooled condensers, and all the energy recovery requirements for exhaust systems and for fluid systems. So including like refrigeration condensers and steam condensate and process heat. They're all grouped together in section C403.9. All of the ductwork and piping related requirements are located in section C403.10. The controls requirements for heating systems that are located outside of a building, such as patio radiant heaters, and then all the freeze protection control requirements, they're in section C403.11. And then in section C403.12, this defines a new single zone high efficiency VAV option that will be an alternative to DOAS. And then lastly, section C403.13 is just a pointer to chapter C408, which is where you'll find all the commissioning requirements for mechanical systems. So we hope this reorganization summary is helpful. ETC has put together a comparison of the mechanical provisions between the 2015 and the 2018 that we'll make available as a supporting resource, so it's easier to find the provisions that you're looking for. So now, let's move on to dedicated outside air systems. This provision was introduced in the 2015 WSEC. The purpose of this requirement is to decouple the delivery of ventilation air from space conditioning. Traditional HVAC systems are sized for peak heating or cooling conditions. When there is no call for space conditioning, this system has to operate often outside its optimal range to continue to provide the necessary ventilation air for the building occupants. This system approach provides energy savings in two ways. Decoupling ventilation from heating and cooling enables the space conditioning system fans, circulation pumps, and thermal unit fans to shut off when there's no call for heating or cooling. This provision also requires energy recovery, which reduces the amount of heating energy required to temper the outside air. This approach provides better control of the delivery of ventilation air to the space, which in turn can improve occupant comfort. A dedicated outside air system can be paired with many common and emerging technologies, such as ductless heat pumps, variable refrigerant flow systems, radiant floor or perimeter radiant heating systems, and chilled beams. It could even be paired with packaged rooftop air handlers, provided the outside air intake in the RTU is controlled to open only during economizer operation. The most substantive change to the DOAS provision in the 2018 WSEC is that the scope of this requirement has been expanded to include more occupancies. The scope is now defined based on IBC occupancy groups, which is listed in a new table in the code. In general, it's been expanded to include most high occupant density and business-related occupancies. During the 2015 WSEC code cycle, the Washington State Building Code Council provided some helpful guidance about the specifics of where DOAS is required. Some of this guidance has been incorporated into the new code, and some may no longer be applicable. However, one common question they addressed was with regards to accessory occupancies. Per the IBC, an accessory occupancy is an area within a building that is auxiliary to the primary building occupancy. So for example, a retail gift shop within a building designated as a museum would be considered accessory as long as the square foot area of the gift shop does not exceed 10% of the floor area of the store that it's located on. Per the SBCC official interpretation, accessory areas are not required to be served by a DOAS. So here's an overview of the types of building areas that will be required to be served by a DOAS. It's been expanded under Group A1. Originally, it covered fixed seating assembly areas, and so now all theater and concert halls are required, but what's still exempt are television and radio stations. Under Group A2, it added casino gaming areas, but still exempt are restaurants, cafeterias, and taverns, bars, banquets, any food service facility. Under Group A3, and that's where the libraries are, and it also now adds lecture, community exhibit halls, courtrooms, gyms, and places of religious worship. A4 and A5 are still exempt. And Group E, that includes the primary education, and then it now includes all other occupancies under Group E, which includes daycare centers and then educational rooms that are accessory to a place of religious worship. Under Group B, that covers general offices and secondary education, and now all other space types under Group B are included. So the dentist's office, the banks, radio and television, the stations, barber and beauty, print shops, dry cleaning, all those spaces now are required to be served by a DOAS. But what is still exempt are the ambulatory care facilities, the veterinary clinics, any kind of lab, food processing, and data processing. And what's still exempt is Group F, H, I, R, S, and U. And then for mercantile, DOAS is required in all areas utilized for the display and sale of goods. So your clothing stores, sporting goods, the food markets, automotive sales areas, all of those types of spaces are required to be served by a DOAS. So what about alterations? For a mechanical alteration project, whether DOAS is required depends on the condition prior to and after the alteration. If the project is an existing system that is being altered, or just a part of the system is being replaced, then the DOAS requirement does not apply. And if it's a heating only system, then DOAS is not required in that situation as well. If cooling is being added to a space that was not previously cooled, then you can comply either via DOAS or you can apply via the economizer requirement. If mechanical cooling equipment is being replaced, and this would include either switching to a different cooling system type, or if it's just a like for like, then you can either show compliance via the DOAS provision or via integrated economizer. And then there is an exception that allows alternate energy saving strategies in those scenarios where there are constraints within the existing building that would make compliance with either the DOAS or the economizer provision impractical. So there are two changes to the performance requirements for DOAS. A system may comply via sensible only energy recovery effectiveness, or it may now comply via enthalpy, which accounts for both sensible and latent recovered energy. Also, for fan efficiency, the code now defines a maximum of 1 watt per CFM for a DOAS with total fan motor horsepower less than 5 horsepower. For a DOAS with fan motor horsepower equal to or greater than 5 horsepower, the system is required to comply with the usual fan power limitation requirements. And note that that 5 horsepower threshold, it needs to include the fan power for the supply fan, the exhaust fan, and any recirculation fans like a ceiling fan that is used for the purpose of ventilation. The exceptions that allow a DOAS to not have energy recovery, they haven't changed. However, note that the fan efficiency requirement, the exception only applies to DOAS with total fan motor horsepower less than 5 horsepower. For those larger systems, you have to comply with the usual fan power limitation provision, as usual. So recall, there is an exception to economizer for areas and spaces that are served by a DOAS. Now, this exception is helpful as it allows higher efficiency cooling equipment that does not have the capability of having an economizer to not have to comply with the economizer provision, provided that the equipment or system is paired with a DOAS. So, for example, a common one are with ductless heat pumps. The 2015 WSEC allows this exception to be applied to packaged rooftop units. However, this doesn't make much sense for an air handling equipment that is installed outdoors or adjacent to the outdoors and thus can be readily provided with economizer. So this allowance has been removed in the 2018 WSEC. And the original requirement for this exception has not changed. So the year-round cooling loads in the space that the DOAS serves from lights and equipment cannot exceed 5 watts per square foot. So if you're installing a DOAS system that you're pairing with your heating and cooling system, and if it can meet both of these criteria, then you can take this exception for economizer. Now, there are 2 cases when a space that would normally be required to be served by a DOAS may avoid this requirement. The first one is if the space is going to be naturally ventilated. Do note that if that's the plan, that you do need to demonstrate that the space will be provided with the required ventilation air during all occupied periods, even during inclement weather. We actually receive quite a few questions about that particular detail, and jurisdictions do want to verify that. And also, if the space is mechanically cooled, you may still have to provide economizer, so do look into that detail as well. And then there is the exception to DOAS if the alternative system that's being put in meets the high efficiency variable air volume requirements. Now, this part has changed a little bit in the 2018 code. There are now 2 high efficiency options. So for high efficiency multiple zone VAV, those systems, if they serve occupancy classifications other than group A1, A2, and A3, those can be applied to in lieu of complying with the DOAS requirement. And then for group A1, A2, and A3 occupancies, you can utilize the new high efficiency single zone VAV system provision. So you can do that in lieu of DOAS. So now let's run through a few of the common questions we received through our technical support about the DOAS provisions. Note that these questions are also listed in our WSEC website under FAQs. So first of all, can ventilation air from a DOAS be heated or cooled before being delivered into the zone? The question is yes. The DOAS unit can have integral heating and cooling as long as it's just tempered or just sized to handle tempering of outside air. So that's okay, but the actual heating and cooling capacity for space conditioning needs to come from the HVAC system. Another question we get is, can the heating and cooling system fans be used to provide destratification and mixing of ventilation air within the zone when the heating and cooling system is in deadband mode? And the answer to this is yes. There is an exception to the criteria that the heating and cooling systems must be turned off in deadband mode. You can use those heating and cooling system fans as long as while it's in that mode that the fan power required for those fans does not exceed 0.12 watts per CFM. Now this question is actually interesting. We've received this question in a variety of different ways. So what approaches can be used to deliver DOAS ventilation air into the occupied space? This was addressed via official interpretation by the State Building Code Council, at least some parts of this. So you can either deliver directly into the occupied space, or you can deliver via the supplier ductwork as long as it is introduced downstream of the terminal heating and cooling coils. You can also deliver it via the fan power units or fan power terminal units as long as when those terminal units are operating during that deadband mode that the fan power does not exceed 0.12 watts per CFM. And then you can also route it directly through an active chilled beam. So with regards to efficiency credits, we will cover all of the additional efficiency credit changes in a future webinar later this summer. So this is a sneak peek to explain the changes to the efficiency credits for spaces served by a DOAS. Note that in the 2018 WSEC, these are referred to as credits, so not options. So there are two key changes. First of all, spaces that are required to comply with the DOAS provisions, they're no longer allowed to take credit for this to meet the required additional efficiency credits. So in other words, no more double dipping. The other change is there is now a new high efficiency DOAS credit. So those qualifying systems are required to have at least 80% sensible heat recovery effectiveness, and the fan efficiency must be less than 0.5 watts per CFM. Note that for those spaces that are not required to comply with DOAS, if you install a DOAS system and it is a high efficiency DOAS system, then you can apply both credits. In follow-up to our webinar about the building envelope provisions, let's go over a few related mechanical system details for semi-heated spaces, greenhouses, and small equipment buildings. There are several updates to the mechanical system requirements and allowances for semi-heated spaces, greenhouses, and equipment buildings. In general, these updates were incorporated to promote the use of higher efficiency mechanical technologies for these building types. So why might an owner or designer pursue eligibility under one of these building categories? For a qualifying semi-heated space, they are exempt from the prescriptive wall insulation requirements. So if the architect or building owner would like to avoid that requirement in their building, then they do need to coordinate with the mechanical engineer or contractor ahead of time to make sure that the systems that are going to be installed meet the criteria so that the building would be eligible as a qualifying semi-heated space. And qualifying greenhouses and equipment buildings, they are exempt from all of the thermal envelope requirements in Section C402. So the primary basis for qualifying as a semi-heated space is that the heating system output capacity cannot exceed 8 BTUs per square foot and that there is no mechanical cooling installed. From there, it depends on the type of mechanical system that's going to be provided to serve the space. So there are some changes to the types of heating systems that are now allowed to serve a semi-heated space. So you can have a fuel-fired equipment type. So the typical ones that we see often in semi-heated spaces like unit heaters, in gas-fired infrared heaters, that kind of thing, and that is not a change in the new code. What is new is that you're now allowed to have electric infrared heating equipment as long as it is only being used for localized heating application only. So like for example, this image here you've got an automotive repair facility and they have radiant heaters over the work base. That's the type of system that we're talking about. You can also now install a heat pump as long as the cooling capacity is permanently disabled. And if you would like to do that, you do need to get pre-approval by the jurisdiction ahead of time. And as always, standard electric resistant heating equipment is still not allowed. So just the electric infrared, that is now allowed, but standard electric resistance like baseboard is not. Now for greenhouses, they are now required to meet minimum, although modest, envelope performance requirements. And then in addition, there is new criteria for the types of mechanical systems allowed in a qualifying greenhouse. So no mechanical cooling is allowed in a greenhouse. However, exhaust fans to move air through the space and evaporative cooling systems, those are okay. And there is now new criteria for the types of heating systems that can be used in a greenhouse. In the previous codes, there were no guidelines about the types of heating system that could be installed. So this is a new criteria for this building type. You can install radiant systems, condensing fuel-fired systems, or heat pumps with the cooling capacity permanently disabled. So same thing as semi-heated, and you do need to make sure that you get pre-approval by the jurisdiction ahead of time. Equipment buildings are those small buildings used to house various types of equipment, such as generators and pumps. This does not include equipment shelters used solely for personal wireless service facilities. Those types of buildings fall under the low energy building category. So a qualifying equipment building is required to meet all of this criteria here. The heating capacity limit, which is set at less than 17,000 BTUs, that has proven to be an issue for designers wanting to use heat pumps because due to the high electric equipment power density requirement, the HVAC equipment is sized based on the cooling load. And then for the corresponding heating capacity that comes in the heat pump, there typically isn't a lot of flexibility with capacity, so you kind of get what you get. So to solve this problem, an exception has been added that allows the heating capacity of the heat pump to exceed 17,000 BTUs as long as the equipment efficiency is 15% better than the code minimum required efficiency for that heat pump. So now let's cover a few details about TSPR. The purpose of this new requirement is to provide a way to evaluate the overall efficiency of a system and compare this efficiency to a baseline system. By highlighting overall system efficiency, this new provision encourages better mechanical system selection and promotes higher efficiency at the whole system level, where there is greater potential for energy savings. To demonstrate compliance with the TSPR requirement, the designer compares their proposed mechanical system to a prototype prescriptive baseline system. This is done using the new TSPR software program developed by the Pacific Northwest National Labs. Think of it as modeling light, accomplished with a user-friendly tool that does not require modeling expertise to use. The tool calculates the annual heating and cooling loads divided by the annual carbon emissions of the HVAC system. This provides an apples-to-apples way of comparing common systems. So here's an example of what the output report from the TSPR web tool looks like. To comply with this requirement, the proposed building TSPR score must be equal to or higher than the baseline building score. So the larger the number, the better the score. So now, what everyone wants to know is, when is this new provision required? So all systems that serve office, retail, library, and education occupancies that are subject to the DOAS requirements without taking any of the exceptions to DOAS, they are also required to comply with the TSPR provision. Note that all of the information about the TSPR requirement are defined in new Appendix D. There are many exceptions to whether you have to comply with this requirement. We're not going to go through all of these today. We'll touch on a few, and then the training that is coming up about TSPR, they'll go into a lot more detail. But just real quickly, those buildings that have less than 5,000 square feet of conditioned floor area, they are not required to comply with the TSPR requirement. And if the HVAC systems proposed for the building, if they match the standard reference design, then a TSPR score is not required in that case either. And then from there, it really depends on the types of systems that are going to be incorporated as part of the project. And so do go through the list to see if your particular project is going to have to comply with this requirement. And then with regards to alterations, typically the TSPR score will not be required unless the mechanical alteration substantially replaces the entire HVAC system. So we've covered just a brief overview of this new requirement. On June 3rd, we will welcome Heather Burpee from the Integrated Design Lab and Supriya Goel from Pacific Northwest National Labs to provide much more information about this requirement. The topics that will be included in the training will be, an overview of, again, what total system performance ratio is and when it will be required by code. And then they'll get into much more detail about how the TSPR score is calculated. And then they'll do a click-through demonstration of the TSPR web tool that's been developed by PNNL. If you're interested in joining this training, go to our WSEC website for a link to register. We will also be sending out an email invitation to everyone who is registered for this mechanical webinar today. Okay, so that concludes our training today about the key changes in the mechanical provisions in the 2018 WSEC. Thanks so much for listening. We received several questions via chat. In the time remaining, we'll go through a few of your questions and share our initial feedback. After the webinar, we'll put together a list of all the participant questions posted along with responses from our Energy Code technical team. We'll send out this Q&A list as a supporting resource via email to everyone who's registered. This webinar is being recorded and will be posted on our new WSEC website along with the completed Q&A list. So we've got a large live audience again today, so do bear with us as we switch over to the chat questions portion of our presentation.